Morning, students. Welcome to another session today. Yesterday, we started a new topic on advanced predictive modeling. We spoke about developing model using binary logistics, regression, and assessing their performance. We looked at the key terminology. We looked at the purpose of regression. We look at what is regression analysis. We look at linear and non-linear regression analysis, among other one. We also looked at a video on YouTube that explained what linear regression is. So today, we'll be looking at developing applications for multinomial logistic regression and ordinal logistic regression. This is the indicative content as usual. The multinomial and ordinal regression intrinsic ordering. Multinomial logistic regression, polytomos LR, multiclass LR, softmax regression, multinomial logit, M-logit, the maximum entropy max nth classifier, and the conditional maximum entropy model. Ordinal regressions, ordered logits, and ordered probit. Use R or Python to create models. So in our previous classes, we've talked about what data science tools are. So today we'll be looking at R, which is an example of data science tool. So what is R? The tool that is widely used by data analysts is R. R is an open source programming language and software environment for statistical computing and graphics that is supported by R Foundation for Statistical Computing. The R language is widely used among statisticians and data miners for developing statistical software and data analysis. So why R? So data analysis and visualization, apart from being one of the most dominant analytics tools, R also is one of the most popular tools used for data visualization. Programming and statistics language, apart from being used as statistical language, can also be used as programming language for analytical purposes. Another example that we have is Python. Python is a very popular one that literally most everyone knows. So Python is an interpreter high-level programming language for general purpose programming. It has a design philosophy that notably uses significant white space, preferred from data scientists for its simplicity and high performance. Ease of learning. R has a stiff learning curve, difficult at the beginning. Python is a preferred language as a beginner. Have to walk through using code samples to create data science use case. So the difference between Python and R, the speed. R is a low-level programming language. Python is a high-level programming language. Data handling capacity, the differences. R is convenient for analysis due to the huge number of packages and ready usable tests. All the packages such as NumPy has improved from the latest version. Graphics and visualization between R and Python. R, easy and better for visualization and more effective than raw values. Python, complex and tedious, gives a tidy output, amazing visualization packages. Deep learning support. Two new packages have been added to improve the performance. New to deep learning. Python works amazing through the libraries. So what about the flexibility? R is easy to use. Statistical tests and models are available to use. While in Python, flexible language when it comes to building websites and applications. Huge with the code repository and library. Huge repositories, more libraries. Less library, more complex to install, NumPy, matplot, etc. So about the popularity index. R is less popular, while Python is more popular. Job scenario. So we'll be looking at a scenario. So Python has a slight edge over R due to the high demand and simplicity. So obviously, like in most jobs or in most organizations, they prefer Python because it has slight edge over R due to the high demand and simplicity. Community and customer support. They both have online community but no customer support. Commands in R. We have variables, we have data types, we have operators, we have conditional statements, loops, strings, and functions. So we'll be looking at how to download and install R. If you have Windows, it's quite easy because we can literally just go to Google or you can click here. So this will take you to where you download R. So this is the link that you download R. But if you are using another operating system like Linux or Mac OS, you can just Google. Yeah, so it will bring you here so you can download R here for Mac and also for Linux. You can download it here for Linux. So this is for Mac, this is for Windows, and this is for Linux. So Linux, Debian, Fedora, Red Hat, Ubuntu, and all. Yeah, so that's it. That's the link there. So we have variables. Variables are nothing but reverse memory to store values. This means that when you create a variable, you reserve some space in memory. So we can say x is equal to 15, and then y is less can be hello, and true can be b. What is data type? A data type in programming is a classification that specifies which type of value a variable has and what type of mathematical relation or logical operations can be applied to it without causing an error. Before I forget, if you want to know more about the difference between R and Python, you can see on the sample website here on the differences between R and Python. So you can visit this website. We show you what the differences are. Let's continue. So we've spoken about what data type is. So what is a vector? Vector is a sequence of data elements of the same basic type. There are 5 atomic vectors, also termed as 5 classes of vectors. Give us a second. So the next topic is evaluate the differences between multinomial and ordinal regression. What is multinomial regression? Multinomial regression and ordinal regression are 2 types of regression analysis used in statistical modeling to predict categorical outcomes. The main difference between the two is the type of outcome variable they are used to model. Multinomial regression is used to model a dependent variable that has 3 or more nominal unordered categories. The goal of multinomial regression is to predict which category the dependent variable is likely to fall into based on a set of predictor variables. The predictor variables can be continuous, categorical, or a combination of both. What about ordinal regression? Ordinal regression, on the other hand, is used to model a dependent variable that has 3 or more ordinal or ordered categories. The categories are ranked in a particular order, and the goal of ordinal regression is to predict the relative ordering of the categories based on a set of predictor variables. The predictor variables can also be continuous, categorical, or a combination of both. So what are the key differences between ordinal and the other one, which is multinomial? So the key differences between the two is the nature of the outcome variable being modeled. In multinomial regression, the categories are nominal and ordered, while in ordinal regression, obviously, the categories are ordinal and ordered. So the first one is nominal and ordered. The other one is ordinal and ordered. This difference in the nature of dependent variable being modeled leads to differences in the types of statistical models and techniques used for analysis. So we have a discussion between the two with example. Logistic regression is designed for two class problems. Modeling the target using a binomial probability, distribution function, the class label are mapped to 1 for the positive class or outcome and 0 for the negative class or outcome. The fit model predicts the probability that an example belongs to +1. By default, logistic regression cannot be used for a classification task that have more than 2 class labels, so-called multi-class classification. So this is an example of multinomial logistic regression. We have the probability of A, probability of C, and the probability of B. So in this equation, it says, imagine a dependent variable with M categories. J is equal to 3, voting for Bush, Gore, or nada. Probability of person I choosing category J must add to 1.0. And this is the formula that you can use to calculate that. The next one is discuss ordinal logistic regressions with example. Ordinal logistic regression is used when there are 3 or more categories with a natural ordering to the levels, but the ranking of the levels do not necessarily mean the intervals between them are equal. Example of ordinal response could be the effectiveness rating of a college course on a scale of 1 to 5. Level of flavors for hot wings. Medical condition, good, stable, serious, critical. Diseases can be graded on scales from least severe to most severe. Survey respondents choose answers on scales from strongly agree to strongly disagree. Students are graded on scale from A to F. So right here, we see develop models for nominal and ordinal scaled dependent variable in R or Python. So we have nominal data. Nominal data is categorical data that may be divided into groups, but these groups lack any intrinsic hierarchy or orders. Examples of nominal data include brand names like Coca-Cola, Pepsi, Sprite, varieties of pizza toppings, pepperoni, mushrooms, onions, and hair color. Hair color, which includes blonde, brown, black, etc. Ordinal data on the other hand describe the information that can be categorized and has a distinct order or ranking. Levels of education, which is high school, bachelor's, master's. Levels of work satisfaction, which extremely satisfied, neutral, unsatisfied, very unsatisfied. I mean, extremely satisfied satisfied, neutral, unsatisfied, very unsatisfied. And star ratings, which is 1 star, 2 star, 3 star, 4 star, 5 star, are a few examples of ordinal data. Understanding data types in pandas. By now, we should know what panda is, and we should obviously have it on our laptop or computer or any device that we use. So the widely used Python open source library Panda is used for data analysis and manipulation. It has strong capabilities for dealing with structured data, including as data frames and series that can deal with tabular data with labeled columns. Pandas also provides several functions to read and write file types, CSV, packet, database, etc. When you read a file using Panda, each column is assigned a data type based on the inference. Here are all the data types Panda can possibly assign. Numeric. This includes integers and floating point numbers. Numeric data is typically used for quantitative analysis and mathematical operations. String. This data type is used to represent textual data such as names, addresses, and descriptions. Boolean. This data type can only have 2 possible values, true or false. Boolean data is often used for logical operation and filtering. This data type is used to, okay, my bad, we have datetime. This data type is used to represent dates and times. Panda has powerful tools for manipulating datetime data. Categorical. This data type represents data that takes on a limited number of values. Categorical data is often used for grouping and aggregating data. Give me a second. We also have objects. This data type is a catch-all for data that does not fit into the other categories. It can include a variety of different data types, such as lists, dictionaries, and other objects. So the next example is understanding data types in pandas. So we have panda data type, Python type, NumPy type, and usage. We have object, string Unicode, and text. In 64, we have int, and among other things. These are the example of the data types in pandas, in Python, and the usage. We have bool. Bool is either true or false, 0 or 1. So this is the type in Python, and this is the type in NumPy. And we also have true false values. We have the datetime, and we also have the time delta, which is different between 2 datetimes. We have the category finite list of text values. We have float 64, which is float under Python type, which is float 16, float 32, float 64 under NumPy type, and floating point numbers. This brings to the end of our session today. Don't forget to write us and don't forget to submit your assignment. Just to recap, today we spoke about develop applications of multinomial logistic regression and ordinal logistic regressions. We also looked at what data science tool R is. We also looked at what R is and why we need R. We know that it is used for statistical problems and obviously for data analysis and visualization. We looked at Python. We looked at the difference between the 2 languages, ranging from ease of learning, speed, data handling, graphics and visualization, deep learning support, flexibility, popularity, job scenarios, among other things. We also looked at the commands in R. We looked at how to install it, which can be found here. But before we go, I think it makes sense for us to see a video on how to install it. I know it's not good, but I would probably assume that literally everyone uses Windows, so I'll Google, I'll put how to install R on Windows. So we have this short one here, so I don't waste our time.
I saw that Yes's culture
This is
was
very short.
quite more relatable to me and so on. So like I'm more of a
Hi, in this video, I'm going to show you how to download and install RStudio. To learn an easy way to install RStudio, simply follow the steps as shown in this tutorial. RStudio is an integrated development environment for the programming language R. With RStudio, user can write and execute R code, visualize data with interactive graphs and charts, and collaborate with other R users. To install RStudio on your computer, open the link given in the video description. The first thing you need to do is download R, which is a programming language that RStudio is built on. Now in the first option, you will see Install R. You have to click on Download and Install R. A new window will appear. Choose your operating system, Linux, Mac, or Windows 10 and Windows 11. As I am using Windows, so I'm going to click on it. If you are installing R for the first time, then click on Base. You will see the latest available version of R here. So you have to click on Download R for Windows. The download has started. So once it's complete, click to open it. Now follow the on-screen instructions to complete the installation. Choose your language. Choose the installation location. Leaving everything to default, click Next. Installation has started. Installation is now complete. Click on Finish. Once you have installed R on your computer, you can now proceed to the next step, which is to download RStudio. So open the same link. And in the second option, click on Download RStudio Desktop for Windows. The download has started. It will take some time depending upon the speed of your internet connection. The download is complete now. Click to open it. Now follow the on-screen guide for the installation. Click Next. Choose the installation location. Next. Install. The installation process has started. RStudio has been installed on your computer. Click Finish. Now if you go to Desktop, in Windows search bar, type in RStudio and click on RStudio to open it. So that's it. We have successfully installed RStudio on our computer. Don't forget to hit the like button and do subscribe to my channel for more videos like this. Thanks for watching.
Hi, we're a web design platform called DEC. This is what our platform looks like. And this
brings to the end of our class again today. Thank you for attending. Don't forget, if you have any questions or submit your assignments, send it to the email shown above, and I'll see you again next time.